Good morning. Today we're going to start our study of probability, which is our last topic in general over the next few days of the year. So if you would open your Inspire document titled Probability and go directly to page 1-2, we'll start with some vocab, of course, and then move into some problems. So on page 1-2, probability is an estimate of an outcome in repeated trials. Theoretical probability is the ratio, so fraction, of the number of elements in an event to the number of equally likely elements in the sample space. So now you have to go back to yesterday's vocab and think about what an event is and what a sample space is, and apply those vocabulary words to today's probability topic. Okay, so on page 1-3, the probability of an impossible event is 0. If something can't happen, its probability is 0. The probability of a certain event, the probability that you're certain something's going to happen, the probability that I'm going to have Algebra 2 trig class on any Monday, Tuesday, Wednesday, Thursday, or Friday during the regular school year. Certain you're going to have class, the probability is 1. Or you're certain the sun's going to come up today, probability is 1. Every other probability are written as a fraction whose value is between 0 and 1. So if you do a probability problem and you get an answer that's negative, or you get an answer that's bigger than 1, you've done something wrong. If the probability of an impossible event is 0 and a certain event is 1, then everything else has to be between impossible and certain, between 0 and 1. All right, so let's do some samples. Go to page 1-4. And this is real kind of elementary basic probability stuff that you've done before in other math classes. So it's a nice review of that, and what we do for the after today is apply old probability skills to new situations. So today's a nice review day again. All right, so let's talk through some of these examples. Number 1, when a die is tossed, what is the probability of the die showing a number greater than 7? Well, on a die, the numbers are 1 through 6, so there is no 7, so that's impossible. The probability is 0. When a die is tossed, what's the probability of the die showing a number less than 7? Well, all of the numbers are less than 7, so the probability is certain, it's 1. So again, just two examples of an impossibility and a certainty with probability. And number 3, when a die is tossed, what is the probability of the die showing a 2? Well, there is 1 2 on any given die, and there are 6 sides, so 1 out of 6. 1 chance of the 2 events happening out of the total sample space of 6 possible events. Number 4, when a die is tossed, what is the probability of the die not showing a 2? Well, if the probability that it will show a 2 is 1/6, then the probability that it will not show a 2 is 5 out of 6. 5 of the sides out of the 6 sides do not have 2's on them. One thing to come from this problem is you need to know the not rule for probability. You'll see why in the next few days we use it a lot. So the probability of an event not happening is equal to 1 minus the probability of that event happening. So if I did 1 minus 1/6 for the probability of a die showing a 2, I get 5/6. So the probability of something not happening is 1 minus the probability of something happening. Okay, on page 1-5, we can combine our knowledge of permutations, combinations, and now probability into one problem. We're going to do a couple of these and be done for the day. So here we are on page 1-5. We have 8 boys and 12 girls in a club. 2 boys and 2 girls are to be selected at random to represent the club at a tournament. What is the probability? So you need a fraction answer that Jacob and Emily will both be chosen. Okay, so what you need to think about here are a couple of things. For probability, you need a fraction answer. And the denominator is always the total sample size, the total sample space, the total number of possible outcomes. So in this case, I have 20 kids, and I'm choosing 2 to be on a team or in a club. So the denominator of this fraction will be a combination, and we'll write this down in a minute. In the numerator, you need to split it up. I have 8 boys that I'm choosing 2 from, and 12 girls that I'm choosing 2 from. And in probability means multiply. And again, we're choosing boys and girls, and the order of which I choose them doesn't matter. If Sue and Emily are on the team, it's the same as Emily and Sue. So those are combinations as well. So we'll go to paper and write that down to show the work. With probability, you never have to reduce your fractions. And so just don't, because you'll start getting confused if your answer is different from mine. On page 1-6, here's some more examples. The letters of the word cabin are rearranged at random. What is the theoretical probability, sorry about the K in there, that one arrangement chosen at random will begin and end with a vowel? Okay, so there are 5 numbers altogether, or 5 letters altogether. 2 of them are vowels, A and I. So to begin my word with a vowel, there are 2 vowels to choose from out of 5 letters. So that is the fraction 2/5. Okay. First letter is, there are 2 chances, 2 vowels out of 5, 2 out of 5. My next letter would be a consonant. So there are, I'm going to multiply that by 3 consonants out of 4 letters left, because I've already used one of my vowels, one of my letters. I'm going to multiply that by, whoops, get out of your fraction, multiply that by, now I have 2 consonants left out of 3 letters. Multiply that. I have 1 consonant left out of 2 letters. And I need to end my word in a vowel. Well, I have 1 vowel left out of 1 letter. And so that's the setup for that particular problem. So you have to think through each problem individually and kind of visualize it. And then you do the math. You just multiply straight across. 2 times 3 times 2 times 1 times 1. 2 times 3 is 6. Times 2 is 12. So my numerator is 12. And the denominator, 5 times 4 times 3 times 2 times 1. Notice that's 5 factorial, or 5p5. The letters can't repeat, so it's a permutation. 5 times 4 is 20. 3 times 2 is 6. 20 times 6 is 120. And you can leave that fraction alone. 12 over 120 is perfectly fine. If you reduce, you get 1/10, but you don't need to reduce. Okay. Here we go. Page 17. Last example of the day. The student's attendance record for 1 semester is shown on your data table. So in your lab packet, there's a data table. It says probability data set of absences and frequency of those absences. If 2 students are chosen at random, what is the probability that both students have fewer than 2 absences? You're going to round your answer to the nearest 100th. So go to your lab packet and that probability data set, and we'll look at it and talk through it. So here's our data set that goes along with page 17 on your Inspire document. And you need to, first of all, add up those frequencies to see how many students we're talking about. So go to your scratch pad on your Inspire and add those numbers up. I don't think you need to listen to spreadsheets for this. You're not going to be doing anything else with it. So just simply add them up. Again, if you're really good at this stuff, you can fast forward and not have to listen. Okay, so we're talking about 140 students. So my total frequency of absences, or my total number of students, is 140. Now the question's asking for how many students have fewer than 2 absences. So there are 37 students with only 1 absence and 12 students with 0 absences. So 37 and 12 is 49. And the question is asking about two different students. So the first student, the chance that my first student picked has fewer than 2 absences, and multiplied by the probability that my second student chosen has fewer than 2 absences. So there are 49 students with fewer than 2 absences. So the probability of the first student chosen is 49 out of 140 students. Multiply that by 48 out of 139, because you've already accounted for one of the students with fewer than 2 absences. Again, grab your scratch pad, punch that in quickly. I do numerator times numerator, and then denominator times denominator, because in probability I really don't want reduced answers, because then I can check that my process and my math was good. Copy those numbers down. So that probability is 2352 over 19,460. But always go back and reread the original question, otherwise you'll lose a rounding point. And here the question specifically said round to the nearest tenths or hundredths. So you go back to your Inspire, you do the division, you're still going to get a fraction answer. I'm just copying those values in so I don't have to retype them and make mistakes. And then remember, Control Enter approximates fractions to decimals. So I have 0.120863. I copy that down onto my paper, reread the question again, make sure I round accordingly, and let's see. We're going to round to the nearest hundredth, which is 2 places after the decimal. So 0.12 is the probability that I'm looking for. And that is it.